Bonsoir tout le monde, ici c'est Aladdin Physics avec un nouveau physics vidéo. Et sa vidéo là c'est pour un étudiant de A-level. Et nous avons un cours de Derivation of Force for a Variable Mass System. Alors là, on va commencer avec une masse, capital M, moving forward with a velocity capital V vector. C'est ce qui est arrivé là. Sa masse là, il émet une autre masse. Je veux dire after là. So I'm drawing the after, where it has emitted a little mass with a velocity u, and therefore the velocity of capital M has changed, v becoming v plus dv vector, and the mass emitted is dm, and the mass of capital M changes from m to m plus dm. So we can apply conservation of momentum now. If you look at it, m v vector is equal to u vector dm plus m dm into v plus dv vector. Now if we break the brackets and we have this dm into m v vector plus m dv vector plus v vector dm plus dm dv vector. Now this term can be removed because it's small. Okay, we can remove that term, and we can remove that term as well because it gets cancelled. There it is. We have this cancel out, so we end up with u dm plus m dv vector plus v vector dm. Now let's move everything on the other side and keep this on the right side. So you're gonna have minus u vector dm minus v vector d capital M equal to capital M dv vector. So if I divide by dt, I have it like this. This is also dividing by dt. So here it's simply the resultant force on. It's just the resultant force on capital M. So we can write this now as m dv vector by dt to be equal to minus u vector dm by dt minus v vector dm by dt. Now we can enforce the conservation of mass. Mass also is a conserved quantity of mass. We should have this. M should be equal to dm plus m plus dm. Alors finalement on trouvait ça dm là cancel, et on trouvait que dm, d capital M is equal to minus dm. And this is true because dm by definition is an increase in capital M. So the increase in capital M should be negative of the increase in small m. Because if you are emitting mass, then automatically means your mass is decreasing. The capital M should decrease. So if dm is negative, it means that the mass is being absorbed. Then d of capital M will be positive, means the mass is increasing. So I can divide by dt to obtain it in terms of per unit time, and I get m dv vector by dt to be equal to minus u vector. So I can substitute now the dm by dt, and it become like this. Become a plus d capital M by dt minus v vector dm by dt. So that is. So now we can rearrange a little bit more and obtain it like this. So you're going to have dm by dt with a u vector minus v vector, which is simply the relative velocity, of dm, d small m, with respect to the velocity of capital M. So if we analyze this equation now, m dv vector dt equal to u vector minus v vector dm by dt, we can analyze it separately. So if we have a mass here like this, capital M, let's say it emits, so this capital mass M is going at a velocity of, let's say, v vector like this to the right, and it emits a particle to the right like this with a velocity u. So if u is greater than v, then of course the capital mass M must have accelerated this dm, this small mass emitted. Itulah parce que kisana qui peut accélérer sa masse, c'est sa capital M qui bisa accélérer sa masse là pour faire gagner vitesse. Alors, so you have small u greater than v vector, so this term is positive, meaning we have this as positive. Now since it has emitted small dm, so the dm will be negative, so we have a force that is negative, which means that the capital M will experience a force in the opposite direction, because of course dm has experienced a force in the positive direction from capital M. So from here we already get the force on capital M. Donc si vous avez apprécié cette vidéo là, pas oublier de like et subscribe on the channel et aussi share the video. Merci beaucoup. Until next time.